This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
This episode of Software Engineering Radio is sponsored by Datadog. Datadog is a monitoring platform that helps thousands of companies get visibility into cloud infrastructure, optimize application performance, and avoid downtime. Datadog integrates with more than 200 technologies so you can get immediate insights into all of your databases, your web servers, cloud services, and container technologies like Docker and Kubernetes. Start a free trial today at datadog.com/SERadio.
Hi, this is Edaena Salinas for Software Engineering Radio. Today, Asaf Yigal is joining us from Israel. Asaf is co-founder at Logs.io, a platform powered by artificial intelligence that analyzes logs. Prior to this, he co-founded a social trading platform and worked in executive roles developing an end-to-end performance monitoring platform. I will be talking with Asaf about the log analysis process and the role of machine learning and humans in this. For an introduction to machine learning, check out episode 286, titled Intro to Machine Learning. Asaf, welcome to Software Engineering Radio.
Thank you very much for having me.
You work on a platform for log analysis that uses machine learning. We did an episode on logging and logging infrastructure, episode 220. What information do logs have?
It really depends on the information that the customer or the engineering organization sends. Most common thing, log data includes the operational of how the system is performing. When is every process thread starts and everything that goes along with it. It's basically very custom, and developers write their own logs to the log files.
Mm-hmm. And for your product, what definition of machine learning and artificial intelligence are you using?
So what we do, and when we started a company, we realized that one of the biggest challenges in log analytics is understanding what is actually interesting in the log data. So organizations send and save and store terabytes and terabytes of data on a daily basis. And the biggest question is, obviously, no one's going to go through, like no human being is going to read line by line and understand what is actually interesting in the data. And how do I know that I'm not missing something which is important? Obviously, most log analytics systems are being used today for forensics and troubleshooting, which actually indicates that the problem presented themselves in the log before it presented themselves somewhere else, because the log provide all the troubleshooting forensics information. And the biggest question that we ask ourselves is, how do we find interesting information in the data? And we looked at a bunch of different methods of doing it. And the way we decided to do it is, instead of looking at the actual data, we're looking at how people interact with data, which means that what we do is we crawl the web for every discussion ever created around log data. So we scan different forums and Server Fault and Google Groups and Quora, and all these different places, and we use machine learning to understand, okay, is this thread discussing something which exists in the log? Which product does it discuss? How severe is the problem? Which version is it using? Is there a solution in the thread? Is the solution satisfactory to the person who asked the question? We mine all this data, and we group all the threads that talk about the same issue together, and we came up with the Cognitive Insights, which is a collection of tens of thousands of different signature, meaning if you see this in your log file, this is the issue, or this is the error, this is the severity, and here's a few links to what is actually interesting in the data. And we've also developed a technology that can run and correlate and query all this information on your data in real time as the data passes through. So the way we analyze if things are important to an organization is by using machine learning to analyze whether this information was ever useful or this was actually an issue for other organizations.
Mm-hmm. And your approach is about combining machine learning with those human insights.
Yes, the way we do it and the way we think about it is obviously no human being is going to go through each one of the log lines and understand what's important. The other alternative of running a black box and saying, well, try to find patterns, try to find something like that, the biggest issue with that is that there's a lot of false positives, meaning that if you look at anomalies in IT environment, the entire IT environment is one big anomaly. Every version releases is an anomaly. Every new customer joining is an anomaly. And anomalies are not always indicate an issue, and issues not necessarily present themselves as anomaly. So we would take in the human intelligence, which is what people interact between themselves on the public domain and in our platform, and we combine that with machine power to be able to scan tens of thousands of different issues in real time on your log data. So that's kind of like our combination of the human intelligence and machine power to come up with machine learning and artificial intelligence to be able to say, hey, you've sent us like a terabyte of data. Here are 5 things in the log file you should know about. Here's an issue you have, and you have a problem in your SQL, and you have something that's not configured right in your server. And all of this, we do it obviously automatically.
Yeah. And would another example of an anomaly in a human insight be, for example, Black Friday, where it spikes a lot of sales?
Yeah, definitely. That's an anomaly, which is not that's not a problem. Everybody expects Black Friday to spike the sales, and that's fine and expected. And that's kind of like the things. This is one of the reasons where we've tried out and we believe that doing a black box anomaly, while mathematically possible, its value is limited.
I want to understand more the challenges in log analysis. As you mentioned earlier, the information logs varies from company to company, and there can be multiple formats for logs. What are examples of the multiple formats?
Yeah, so I think the first challenge of log analysis, and this is how we start a company, is how do I get all the logs and aggregate them and normalize them in one location? Every log, like you said, it comes from a different system that sends in a different protocol that is behind firewall, not behind firewall, needs to keep the data secure and encrypted, doesn't need to keep the data secure and encrypted, keep a different format, a different date format, different fields in the log data. And right now, all the process is being done on a manual basis. So a person, an engineer, needs to be able to go to each one of the system that he's using and configure it to send logs to the right location, configure the parsing and the data interaction and the relationship between the data. All of it needs to be done in a manual way. Mm-hmm. And that's kind of like, that's one challenge. It's actually it's a pretty big challenge. The second challenge is what to do with the data, which is what we talked about with AI and the machine learning. The way we address the first challenge is we've taken the most common log analytic solution today, which is ELK, Elasticsearch Logstash and Kibana. And we offer it as a cloud service with enterprise grades, with automatic data parsing, with a bunch of other features which are required in order to build a log analytics solution.
And the ELK that you mentioned, is that for the step where a human is connecting the different log streams?
Yes, ELK is basically where the humans connect all the log stream. I mean, our service Logs.io is an ELK, is a cloud service that is ELK. It's built out of 3 components: Logstash, which is the L in the ELK, which does the data parsing and where the human configures the data structure of each one of the log types. the Elasticsearch, which is the E, which is a search database. It's being used for many, many purposes. One of them is log analytics. And Kibana, which is the K, which is a visualization layer, and you can create graphs. You can run the searches from Kibana, and you can create your own dashboards, and that's kind of like basically the stack that people use. It's completely open source, and we run it as a cloud service.
And the people involved in this part of the process, what programming or analysis skills are required to extract the information from logs?
To involve you're talking about the people that configure the system to be able to extract the log, or the people that we have that build the machine learning and required?
The people that are involved in looking at the logs and finding relations with them and just aggregating them.
Right. So it's a very interesting question, and we do see different personas within the organization treat the logs in different ways. There's the section of the DevOps, mainly the operational people that are responsible to making sure that the system is up and running. What they care about is taking the logs in and to be able to create dashboards and alert and extracting information in a visual way to help them monitor the system, the health of the system. So this is one class of users, and they use it in a very certain way. The second level of people is like the developers, and the developer actually go through the log lines and understand what's going on. So usually what happens is a DevOps or an operation engineer or a site reliability engineer say, hey, we're getting too many errors of this. Can someone please take a look at it? And because he ran an aggregation that gives him a list of all the errors, and a developer is going to look at that specific point of time, is going to look at the services that he is running, is going to read the logs line by line, and he's going to be the one who actually understands what's going on in the log data. But it's definitely, today, especially for organizations that run in the cloud, especially for organizations that run in a Docker or serverless environment where the environment is so dynamic and changes all the time, if you did not aggregate the logs into a centralized location at the point of creation, then your chances of actually troubleshooting an issue are zero, because most likely the data is no longer there. So we live in a world where even a small company can have hundreds of different servers or different services running all across the different parts of the world. And in order to be able to understand what's going on, it's actually mandatory for you to aggregate them into a centralized location. Otherwise, it's completely impossible to do it.
How much data can be gathered per day and by how many sources?
It really depends. We have customers sending us 20, 50 gigabytes a day. We have customers sending us 15 terabytes a day. It really depends on the type of customer that we're working with and the size of the company. One of the things we also realized that when we first started working, we had the theory of this is going to be mainly for cloud-based application, companies that are more innovative. And we see today that it basically runs across the world. We have pharmaceutical companies that are completely not in the cloud. We have manufacturing companies. We have IoT devices that ship logs. The log analytic is really a multitasker that you can do a lot with it. And I think this is a big reason for the success of this domain in the IT operation and IT analytics space.
How long do those logs need to be stored for?
It really depends. Some people save it for 2 weeks. Some people save it for 90 days. Some people save it for 5 years. A lot of it depends on the regulatory environment people live in. Usually for production issues, if you haven't looked into it in 2 weeks, they're either not interesting or they continue to happen again, and you can see them happening over and over again. So usually 2 weeks is I would say 2 weeks to 30 days is the most common use case that we see.
Does that affect the machine learning portion?
No, because the machine learning portion is actually, because we're not looking at the data, the machine learning is running in real time on the logs as they get in. So the moment we detect an issue, then we highlight it to you. And you have to, so I also want to understand a little bit more, explain a little bit more about the machine learning. So the usual process that someone does today, and I'm also a developer, so I've done the same thing that people do today, is usually you run and you're using a lot of open source products, and you're using products that, like, you're not an expert in. No organization can be an expert in all the products. And you see an exception in your log data, and the system is working fine. I mean, you see an exception in MySQL or in Kafka or in Elasticsearch, and things work okay. I mean, until they don't. And then you look at it, and what is the first thing you do? You Google the exception, or you Google the error, you Google the message that you couldn't figure out what it is. And guess what? It happened to other people before you. And the thing that happened to other people before you, you start reading about it, and sometimes it's something that you can fix. It's a small configuration. Sometimes you use it wrong. Sometimes maybe it required a version upgrade. It's a very common thing that people, I mean, environments run with issues in them that nobody is checking. And what we're doing is we're continuously checking for all the possible errors, and we're going to give you kind of like the best solution that we have in order for you to start digging into the problem and understanding what it is.
So as part of the system, you programmatically are querying these other resources like Stack Overflow, forums where other people might have reported an issue, right?
Correct. So we programmatically look into all of them, and instead of you running into an issue and searching for it in Stack Overflow, we search Stack Overflow and we bring the issues to you. Because at the end of the day, all of the log analytics systems that exist today, the value you can get out of it is limited by the question that you can ask. So if you know that there is an issue and you search for it, you will find it, and it's great value. But how do you know that there aren't issues you're not aware of, that nobody reported onto you? So this is what we do, and we highlight all the issues that we have based on our analysis of things that happen and discussion that happen across the world, and we basically bring this to you. We search your data in real time for all the issues.
Before we talk more about this integration with machine learning and human insights from forums and other platforms, I want to understand the machine learning portion in log analysis. What machine learning techniques are useful for this?
So I think one of the most useful machine learning is clusterization, and being able to understand the two different threads talk about one same issue. We also have classifiers that are running, that their job is to be able to say, okay, this issue is the signature in the log. If you found this is the description. It talks about that product. There is a solution here. This is a high severity or low severity or medium severity. So there's classifiers that run and be able to do it. Clustering information, like I said, and also machine learning to understand we have no more than 60 or 70,000 different signature. How do we ask 60,000 questions on every log line that comes in? If customers send us terabytes and terabytes a day, what's the realistic way, and how do we build kind of like an engine that's searching it in real time?
Let's talk about clustering first. When you apply it to log analysis, what are examples of clusters then can be identified? Like, I want to understand, I have logs from Windows, for example, and what does one cluster look like?
So this is the question of clustering. So the clustering is applied in two different dimensions. One of them is understanding clustering the log data itself. And the other one is clustering the different discussions that we grab from the public domain into a single kind of issue, into a single insight, we call them. So clustering of log data itself, this is a great feature, and what it does is to be able to say, okay, logs from the same log type are most likely in the same cluster, and then we run, and some people run like different distances algorithm to be able to detect how far is different logs from one another, and then we do some pattern matching and say, okay, which part of the log line is standard, which one is changing, how do we extract the changing part of it, and we cluster all the same log lines together.
Yes, what I'm thinking more is that I've seen clustering, but in other examples like marketing, like here's the cluster of people that tend to like Hollywood movies, and we found this other cluster of people that watch other type of movies and things like that. So I want to understand in the logs, what exactly does a cluster mean?
So let me give you an example. I mean, let's say you are running a website and you're sending all the access data from your website. So this data comes in, and every message includes the IP address, where it came from, the response code, whether it's 200, which means okay, or there is an error or something like that, how long it took the message to process, which URL was being accessed on your website. And the first clustering is to be able to cluster it by the actual type, saying, okay, these are all logs from the same type. The second clustering is being able to differentiate it and say, I'm going to group all the logs that have the same response together, and I'm going to group the logs that have different response in a different group. So that's one clustering that's being done. But the other clustering that we use is the actual clustering on the threads that we're crawling. So if we see a thread that's talk about a product, let's say we see a thread that talks about Elasticsearch and talk about a specific issue, there are probably 10 other threads that are talking about the same issue. And how do we group them together and say, all these discussions basically relate to the same problem, they relate to the same product, they relate to the same product version, and that's kind of like how we group them together and how we pick the best one out of them. How we say, okay, out of all the discussion that we've seen on a certain problem, this is probably the most helpful one because it has more discussions, it has an answer in it, the person who asked the question acknowledges that the issue was addressed, and that's kind of like how we cluster the discussions.
So there are two parts of clustering, like you're saying. One is done to the logs itself, and the other one is done to this human insight component, which is answers on forums, Stack Overflow, and things like that.
Correct. So it's very similar to what you said about, okay, let's find out all the discussions of people that are interested in a specific movie. So we find all the discussion that are people that are interested in a specific product. And then we find all the discussion that people are interested in a specific product on a specific issue in that product. And that's kind of like how we group the discussions together, and that's kind of like where the value is and where the algorithm stands.
This podcast is supported by Atlantic.net, hosting solution provider of healthcare HIPAA, PCI compliance, and ad tech. If you're feeling the pain of having outdated technology, call Atlantic.net and get the latest security firewall, intrusion detection, backup, disaster recovery, and virtualization. Or if you're starting a new project or not getting the results you want from your current providers, Atlantic.net can help you succeed. With fully audited solutions and 23 years in business, they won't let you down. Visit Atlantic.net to learn more.
Okay. Let's talk about the classifier component. Can you explain a little bit more what these classifiers are classifying?
Yeah, so what they do is they basically go through each one of the discussions and understanding, first of all, which product are we talking about? What's the problem in the product? What's the quality? What's the tone that people are using in order to describe the problem, how severe it is? And that's kind of like what they do. They extract the product, they extract the issue out of it, and that's kind of like how they classify the information.
Is this more when the logs come with a human component? For example, they add a description that a human wrote, and you might want to detect how critical it is or how severe it is?
This is part of us scanning the discussions that people talk about the logs and understanding how severe the discussion is, based on it, how severe the problem is. Yeah, which product are they talking about? That's kind of like how we use that.
So these are classifiers again in the human insight.
Yeah.
Do you have classifiers for the logs themselves?
We do not have classifiers for the logs themselves. We, like I said, I think the way we run things is our whole algorithm is very similar to how, for example, Google ranks his pages and say what's more relevant when you run a search. We rank the logs based on what other people found to be relevant. So we give you the relevance of what's actually interesting in the log file, not based on the data that you have, but based on what other people thought is interesting in their log data.
And where in the loop are humans still necessary in the log analysis?
Humans are always necessary, and one other component in this algorithm is the supervision. So we run supervised machine learning, which means that when we present a customer what the insight is, and let's say, okay, we see this exception, it's high severity, it talks about Kafka, and here are a few threads that talk about it. We measure the interaction of that user with the insight, and if he says, you know what, it's not really interesting, or yeah, it's very interesting, or you talk about a different product, that creates the supervision engine, and that's how we can basically improve both the classifiers and the clustering algorithms.
So as I am understanding this, the machine learning portion is more focused on the component that humans still do a lot, for example, querying on Stack Overflow. So what you're trying to do is making that shorter, the task that humans do, right?
Yeah, what we do is two things. First of all, making the task that humans do shorter, and also, like I said, I mean, you know what to search for based on what you know to search. And what we do is we bring all the searches anyone has ever done in the world and searching your log data. So we make it both accessible and easy to do.
And you mentioned before that you're using supervised learning, right?
Yeah.
How much data is necessary to train the algorithm?
So we run it on a periodic basis and retrain the algorithm all the time. Obviously, you need quite a lot of data, and this is why it's a continuous project and a continuous effort to be able to improve it.
And a component of supervised learning involves, like I said, having the training data which already has labels. In this case, what does the training data looks like? Is it about this post was relevant or not relevant?
Was it relevant, not relevant? What is the severity of it? Is there an issue in it? Which product are we talking about? Which version of the product are we talking about? And so we're trying to do, these are all the features, and we learn from how the humans interact with it and say, hey, well, this was wrong, and that means, okay, let's go back to and retrain the algorithm now on the same data. He needs to find something else, and that's basically how it works.
Who's labeling the training data?
We are labeling all the training data based on the algorithm that we have, and the users of our systems are continuously labeling the training data. So this is the algorithm run and comes up with insights and all the features on top of it, and then we present this to all of our customers and all of our users, and they change or not change the data based on their understanding, and that's goes back into being the training data for the algorithm back again.
So the labeling portion is embedded in the user interface, kind of analogous to CAPTCHA, right?
Correct.
Okay.
Yeah.
You've worked with logs and log analysis, and you've probably seen different formats of logs. Should we change our logs to better serve a machine learning system?
I don't know. I mean, it's a good question. I think that it's very hard to be able to enforce different logging type, especially since today we're using so many open source components that their log structure and the way they write to the log is decided by the person who developed that open source product. So being able to force a structure to be able to do this, I think is it's going to be a very hard task.
One thing that I saw mentioned on a logs IO post is that most of the log data is meaningless. What portion of the data can be used by machine learning algorithms?
The most of the log data is meaningless, and this is why we're not looking at the data. And what we look at when we look at kind of like discussions and how people interact with data, we find that a very, very small percentage of the log data is actually relevant. So this is kind of like our analysis from it.
Is this because we're currently overlogging information, or?
Yeah, I think we're definitely overlogging because we do not want to be in a situation where there is an issue and we do not have enough information to troubleshoot it. So we're definitely overlogging. Most log lines are just saved to a file and are never being read by anyone because they don't represent any issues, but you want them there in case there is issue to be able to troubleshoot, to go back and understand what happened.
Let's talk a little more about the combining machine learning with human insights. For that, what part do you take from a log and decide to query for in other platforms for human insights?
So we take and we start from the actual human insights. So we look at the threads that people do, and we try to find their pieces of log data. So part of the classifiers, we're not looking at people's logs.
Not people's logs, but let's say I have my system and I have all this files of logs. Do you start programmatically looking at these logs and then connecting them with the human insight?
What we do is we have like a pretty big library of all the human insights, and we continuously match every log you run against all the insights that we have in the system. So that's what we do, but we do not look at the log and try to find insights from there.
Okay, so you look at the insights and you try to find those in the logs?
Yeah.
Okay, so this sounds like you have a big library of human insights that you've gathered. Are the systems that you work with, or the companies, are they similar enough that they can share a library of human insights for issues?
Yeah, because that library is big enough, and it scans across tens, if not hundreds, of different discussion places. And that's the power of it. I mean, we really believe that with the world has become so dynamic that's basically the only way to be able to keep track of issues that you have in the system. By doing that, it doesn't only pertain to operational issues and exceptions in the log. I mean, some of it is security insight, because we ran through a security forum and they talk about if you find this in your log file, that means that someone's trying to do a cross-site scripting with you on your website, or someone's going to trying to hack into your website, or you get a password that someone's trying to hack, and all of these things are all documented on the web. So we crawl through all of them, and there's definitely a high degree of correlation between our customers.
And for the classifiers that you run on the human insights sources, do you know what those classifiers are?
Just basic kind of classifiers to be able to detect the issue. And so it's mostly proprietary information that we've developed in-house.
Okay. Yeah, that's what I was wondering. What problems do you think need to be solved to have even less human intervention in log analysis?
It's a good question. I think one of the problems that needs to be solved is the automatic data parsing. So what we've talked about in the beginning, being able to cluster and understand log structure, saying, okay, these 10 million logs are the same structure, and this is the parameters in them, and this is the fixed part. This is a big thing that is being developed, and this is definitely going to help and reduce the human interaction with them. I think that there's always going to be an expert involved, and there's always going to be someone who's going to need to look at how things work, the person who actually wrote the system. I think the other thing which I also wanted to say is that our mission and what we're trying to do is we're not trying to find all the problems that exist in your system, but when we tell you that there is a problem, what we're trying to do is that the system is going to be accurate and there's actually a problem, and that insight is actually relevant for what you're looking for. Because the biggest challenge with IT environment is the whole concept of a noise to value ratio. Because if you have a lot of noise and your system just grows and grows all the time because the company is successful and you get more business and more developers are adding more features and functions, then you stop relying on it because all you see is noise. And we give you a very kind of like a surgical understanding of things that we think are the most important things that you can look for in your log data, and addressing them is going to address a problem before it happens. You don't need to wait for an anomaly detection telling you that there is some sort of an anomaly because you see an error in the log file that says that you're using the wrong configuration on a specific product.
How effective have you found that the insights that you give the users from their logs are?
I think we found it to be extremely effective. We got a lot of feedback from customers that, hey, you highlight an issue I had no idea existed in my system, which is what we're doing. I can tell you some things that we've discovered about ourselves. I can tell you one, for example, we had really early on when we first started a company, a bunch of issues with Elasticsearch. It was like a very old version of Elasticsearch. And we spent probably about a month. This is kind of like way before we've developed the insights, and we couldn't understand what's going on. Why is it disconnecting and why is it happening? And then we kind of launched the insights, and we discovered that there is, when the servers and the machines restart, there is one log line that's saying SKB ride the rocket, which is a scatter gather configuration on Ubuntu. On the specific version that we're using, and apparently there were a lot of discussion about it, that it has adverse effect on Elasticsearch clusters. So we could have like gone through the logs for another 2 months and add more resources and change machine types and change Elasticsearch versions, and we would have never found it. And just by understanding that log line, it was in a completely unrelated location. So it's not, the log line appears when the system starts. It does not appear when the problem happens. But just detecting it and being able to analyze it proved to be very valuable to us. We found customer with issues in Kubernetes, the way they configure it, that they came back and say, hey, thanks. I mean, we had no idea this existed in our system, and we've been trying to chase an issue in a completely different location for weeks now. We have customers that we found hardware issues in their environments, and nobody bothered to look for it because who would think that there is a memory card that is not functioning in one of the server? And yes, it's in the log files, but out of terabytes of data a day, who's going to find that one log line that says I restarted the server and I have an issue in my memory card? So, so far, and again, this is, as you can imagine, this algorithm and this system is an evolving system, but so far, with the evidence we have a lot of proof that's saying it's extremely valuable.
Mm-hmm. Because it does help you find associations and places where it might not be obvious. For example, when I'm debugging or looking at logs, I go and start where the failure was, where the log of the failure, and then go from there. But like you said, it might just be some other aspect during restart. Yeah.
Correct. I mean, it might be some other aspect, something that happened in the system, and it let you know about things that happen before they become an issue. And you say, this is an insight, I'm going to go and investigate what it means. And we give you the beginning of the investigation, which is a few discussion that people talk about it, and you can say, okay, let me read it. Maybe it's relevant. Maybe I'm using the wrong version, and if I just upgrade, this problem is going to go away. Maybe this problem is not that critical, and it's okay that it happens.
Well, Asaf, thank you for coming on Software Engineering Radio. It was great talking to you.
Thank you very much. Thanks for having me.
Users want a simple way to pay. You want an easy integration. Braintree allows you to accept nearly any payment type from almost any device with just one integration. It's flexible to your system's needs and supports most programming languages. And when your checkout is simpler and faster, you're going to have happier customers. That's what we call a win-win. Learn more at braintreepayments.com/SERadio. Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.